So now we get to the fun part, part C. This is the part everybody should get correct. So we're going to use the trapezoid sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree over the time interval 2 to 10. Now realize this is saying the average height, so you do need to be careful here. So this is going to be 1 over b minus a of the integral from a to b of h of t dt. So we need to make sure that we're doing the average. So it's going to be 1 over 10 minus 2, the integral from 2 to 10 h of t dt. So you need to remember that part. We're still basically the trapezoid rule. Just doing the trapezoid rule does not complete the problem. The trapezoid rule is simply giving you the integral. It's evaluating the integral, giving us an approximation to that integral. And I'm not liking my integral signs. Let me write those again. So it's just giving us those approximations, and you still need to complete answering the question itself. So let's go ahead and start with the left sum, because we know the trapezoid sum. The trapezoid sum is going to be equivalent to the left sum plus the right sum divided by 2. It's just the average of the two. So let's start with the left sum. So the left sum is going to be 1.5. So we see that this is our first delta x is 1, then it's 2, then it's 2, then it's 3. So we're going to have 1.5 times 1 plus 2 times 2 plus 6 times 2 plus 11 times 3. And what am I doing? I'm running through the left 4 values. That's the left sum. We're running through the left 4 values, and we're going to see what we get. So we get 1.5 plus 4 plus 12 plus 33. And so 33 plus 12 is 45, 49, and that's 50.5. Hopefully I did that right. Just kind of running through that a little bit too fast in my head, and I do make a lot of mistakes. So we'll come back to it if it's not right and see if I made a mistake somewhere in there. So the right sum, same idea, but we're going to use, instead, this time we're going to use the right 4 values. So we're going to use 2 times 1 plus 6 times 2 plus 11 times 2 plus 15 times 3. So this is going to be 2 plus 12 plus 22 plus 45. And 2 plus 12 is 14 plus 22 is 36 plus 45. 36 plus 45. Man, I am starting to go brain dead here. Too many videos in one day. So that's going to be 70, 81. So our trapezoid sum is going to be 81, or not 81. We're going to go with 50.5 plus 81 divided by 2. So that's 131.5 divided by 2. Need to double check, make sure I'm doing this right. 131.5 divided by 2. And that's 65.75. But honestly, I think I'd rather just clean it up so it's just a nice fraction. So that's going to be 263. If I were to double it over 4, I'm just doubling the top, doubling the bottom. Really getting rid of the decimals in this problem because it doesn't ask us to answer in decimals. This is a non-calculated portion, so we shouldn't have to be dealing with decimals. So that's why I'm getting rid of those decimals. And so that is what we get for our integral. Remember, that's not the answer to the question, so we still need to bring it into this. So the integral, or 1 over 8, really, the integral from 2 to 10 of 263, or not 263 over 4, of our function h of t dt is going to be 1 over 8 times 263 over 4, which equals 263 over 32. And there's no way to simplify that. You can already see this is not an even number, so 4, this is only made up of 2, so it's not going to go into the odd number. And so the average height of the tree And make sure that we answer this all the way. It's not asking for units or anything like that. So use a trapezoid sum with 4 sub-intervals indicated by the data in the table to approximate the average height of the tree over the time. So yeah, that's just it. This is the average height. So by the way, the average height right here, this is 1 point for the answer. And then this is 1 point for using the trapezoid sum. So if you forget to run it through the average value formula, you'll at least get 1 point, half the credit. But if you want full credit, all you have to do is divide it by 8. So please don't miss the little details like that.